So here in this problem, we are given that tangent of alpha plus theta equals to n times tangent of alpha minus theta. So using this condition, we need to show that the given trigonometric equation is true. So let us begin. So we'll start with whatever we're being provided with. So here we are given that tangent of alpha plus theta, that's equals to n times tangent of alpha minus theta. So here we're going to use the identity. That means whenever we have tangent of A plus B, so this can be also expressed as tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. Right. And if we have tangent of A minus B, then in that case, on the right hand side or wherever we have positive sign, that will become negative and the negative will become positive. So let's use this. So tangent of alpha plus theta. So here we'll be using tangent of A plus B identity. That should give us tangent of alpha plus tangent of theta in the numerator, and in the denominator we're going to get 1 minus tangent of alpha times tangent of theta. Right. So this is equals to n times tangent of alpha minus theta. So let's expand this. This is going to give us tangent of alpha minus tangent of theta. Whole thing is going to be divided by 1 plus tangent of alpha times tangent of theta. Right. So let's cross multiply. We get tangent of alpha plus tangent of theta. So this will be multiplied to 1 plus tangent of alpha times tangent of theta. This equals n times tangent of alpha minus tangent of theta whole multiplied to 1 minus tangent of alpha times tangent of theta. We're going to further simplify by multiplying tangent of alpha plus tangent of theta with 1 plus tangent alpha tangent theta, and this is going to give us tangent of alpha plus, so we have tangent of alpha multiplied to tangent of alpha, that gives us tangent squared alpha, and we have tangent theta multiplied to it, plus we have tangent of theta times 1, so that's tangent of theta, plus tangent of theta times tangent of alpha, and we also have another tangent of theta, so we have tangent of alpha multiplied to tangent squared theta. Similarly, we're going to multiply, so let's keep n as the common factor. So here we'll get tangent alpha minus tangent squared alpha times tan theta minus tangent theta plus tangent alpha multiplied to tangent squared theta. Right. So now our task will be to combine some terms. So let's do that. So in the next step, what we'll do, we'll multiply n to each of the terms. Now what we'll do, we'll take this tangent of theta and this negative tangent of theta, we'll combine them and keep them on the left hand side. So here we're going to get n plus 1 multiplied to tangent theta. Next, we're going to look for terms and combine them in such a way that it also has got a factor of n plus 1. So let's check that out. So if we have, so we'll take this term and this term, combine it on the left hand side, and this is also going to have the factor n plus 1 multiplied to it. So n plus 1 times tangent squared alpha times tangent theta. Right. Then we're going to go to the right hand side. So this time we're going to combine n tangent of alpha and this tangent of alpha, and they are going to have a common factor of n minus 1. So this will be multiplied to tangent of alpha. And lastly, we have tangent of alpha plus tangent squared theta. We'll take it to the right hand side and combine with the last term on the right hand side to get n minus 1 times tangent of alpha times tangent squared theta. Now what we'll do, we will consider this term and this term. Here we can take n plus 1 multiplied to tangent theta and take it as the common factor. So this will get multiplied to 1 plus tangent squared alpha. And on the right hand side, we are going to take n minus 1 times tangent alpha as the common factor. So that will get multiplied to 1 plus tangent squared theta. Now here we can use an identity. So we know that 1 plus tangent squared a, so that is equivalent to secant squared a. So you can use this identity to replace 1 plus tangent squared alpha with secant squared alpha and 1 plus tangent squared theta with secant squared theta. So now we should get n plus 1 multiplied to tangent theta we're going to divide both sides with secant squared theta times secant squared alpha, so that we can get rid of the secant squared alpha from the left hand side and secant squared theta from the right hand side. So on the right hand side we have n minus 1 multiplied to tangent alpha divided by secant squared alpha. Fine. Furthermore, we know that the ratio tangent over secant theta, that can be also manipulated. Let's do it here. So we have tangent of theta divided by secant squared theta. So what's tangent theta? That's the ratio of sine theta over cosine theta, whole divided by secant squared theta. So secant function is the reciprocal of the cosine function, so we'll get 1 over cosine squared theta. So this will be equivalent to sine theta times cosine theta. So tangent of theta over secant squared theta, that's equals to the product sine theta cosine theta. And similarly, the ratio tangent alpha, so let's write it down here as well. So tangent alpha over secant squared alpha, using the same logic, we should get sine alpha multiplied to cosine alpha. We're going to use this value, so we get n plus 1 multiplied to sine theta times cosine theta, and this will be equals to n minus 1 times sine alpha times cosine alpha. Now we'll multiply both sides of the equation with 2, so we get 2 times n plus 1 times sine theta times cosine theta, which will be equals to 2 times n minus 1 times sine alpha times cosine alpha. Now here the reason we multiplied by 2, because we know for a fact that whenever we have sine A plus B, so that gives us sine of angle A times cosine of angle B plus cosine of angle A times sine of angle B. So let's say if we take A equals to B. So if we take A equals to B, then we have sine of A plus A, so that's simply 2A. And this will be equals to sine of angle A times cosine of angle A. We're replacing B with A plus cosine of angle A times sine of angle A. Now they are exactly the same terms, so we get 2 times sine A times cosine A. Thus, we can say that 2 times sine theta cosine theta, they will get combined to give us n plus 1 times sine 2 theta. And on the right hand side we have 2 times sine alpha cos alpha, so that should get combined to give us n minus 1 times sine 2 alpha, and this is what we were asked to prove, hence proved.